In item 4, we're given a truss, and all we want to find is the net axial deformation of member AD. This member turns out to be 20.616 feet long, or 247.39 inches. It is subject to an axial load in tension that develops in response to these two externally applied forces to the truss of 10 kips and 10 kips at joints C and D. The cross-sectional area is 2 square inches. The modulus of elasticity is 29,000 ksi, that of steel. A temperature change happens of a minus 85 Fahrenheit degrees, and the thermal coefficient of expansion and contraction is 6.6 times 10 to the minus 6 per Fahrenheit degree. So the key here is to combine both actions, both from the applied forces effects and then from the thermal changes, such that the total strain is equal to the strain caused by the axial force plus that caused by thermal changes, where plus here is going to be related to elongation and minus would end up being related to shortening. Right? And so we can get then, of course, the total deformation by multiplying the total strain by the member length. And so substituting everything in, strain is going to be given to us by Hooke's law. And so Hooke's law being sigma equals E epsilon, and stress being force over area, we'll have P over AE plus our thermal strain being given to us by alpha sub t times our delta t, and then all of that will get multiplied by the length to give us our total deformation. Right? And our axial force is 41.2 kips over our area of 2 square inches, our modulus of elasticity of 29,000 ksi, and then we have a plus 6.6 times 10 to the minus 6 per Fahrenheit degree times our minus 85 Fahrenheit degrees, and then that will be all multiplied by our length of the member of 247.39 inches. And when we multiply that all out, we will find ultimately that we have a net positive elongation of 0.037 inches, plus or minus. And here again, the plus means that we've had elongation. The arrow indicating where the answer is, not the direction of anything.